With the gray and chrome sphere, we have now a light rig setup which matches our reference sphere. So we can be fairly certain that the lighting represents what was captured on set, and now we can start rendering the actual asset. The interesting part with this approach is, in our first render tests, since we have validated our chrome and gray spheres, it also acts as a validation for the asset. If the asset is too bright, if the asset is too dark, it doesn't necessarily mean the light rig is too bright or too dark, but it could mean we have to adjust our look depth because our shader or texture values are not correct. So approaching your sequence light rig using the reference spheres is the best way to avoid any confusion in terms of if your lighting balance is right versus the asset look has to be adjusted. I'm now going to look to the shot camera and view the graph from the character beauty pass. And just expand my set in the scene graph. Right now the samurai is out of frame, so I'm going to go to the last frame just so that I have the samurai full in frame. If you render, you will see that the set is actually visible in the render. And so the set in the render will throw off our lighting a little bit. But either way, as you can see, this is how our asset will, with the light rig, looks like. Let's set up our passes correctly. And the first thing I want to do is actually prune out all the elements from the set we don't need. I won't actually get rid of the set completely, even though we don't want to render it, but I want to use the set for shadowing the samurai, and I want to project the plate onto the set and bounce the correct colors back onto the samurai. If we take a look at the set, I don't want to have all the geometry visible because it would actually occlude the environment light. Since I want to use the environment light to light up the character, I'll remove some of the geometry with the prune node. And again, you do this in a sequence setup, because we want to remove the geometry for all the shots. So add the prune node, and if you expand the set geometry, you can see we've got the higher res geometry. This is the lighter, and we definitely don't want that. We're just going to add it to the prune node. If you look at the low res geometry, we can remove the outer wall and the ceiling, but the rest will be useful for us for plate projections and shadow casting. The windows are going to act as a light blocker for the window light, so it will shape it correctly, and the geometry we'll use to project the plate onto. Now to set up the plate projections, we need another shader, which has a projection shader built in. I prepared a look file for that, which we can load. I won't go into the detail itself on how the shader works, since this is beyond the scope of this course. So look out for VFX Mojo's look depth course. Alright, in the look depth directory in Shadow Shader, load the Shadow Collector KLF. As material path, select the Shadow Collector prelit shader. I'll just call the shader Shadow Collector. The settings are fairly simple. You can set the projection type, the camera you're projecting from, so the current shot cam path should be correct. That would be our shot camera. And then the texture file, this is where we will assign the textures we want to project. Okay, so in the group stack, I'm going to just rename the existing material assigns so we know what is what. And I'll drag the HDB set into the cell statement and assign the shadow collector to it. It's called shadow collector because we will use the shader to capture the set shadows, which we'll cover when we look at HDB 30. Now I just want to set up the projection itself so it loads the correct texture. Create a material node, set it as an override material, and I will assign it directly to the shadow collector shader. And we want the texture file as an attribute. I will load the plate for HDB 10. So let's go to HDB 10 element source, and in here select the neutralized plate. To load not just a static frame, but the correct image per frame, I will create an expression. So make an expression out of the path, and in the expression replace the 1001 with %i. And add a percent and type in frame after that. And now Katana will automatically read in a frame number and replace the frame correctly. So let me call this MA_plate projection. Now we can take a look if it is working. Just render the character path. You should see the colors on the walls have changed. Everything is a little bit darker, and if you compare it with the previous gray render, you can see the color shift on a character, which is a change in terms of indirect lighting on him. Generally, the color tones have gone slightly warmer, which is more in line with the plate. The projection is not a perfect lineup. You can see there are a few problems here, but that's okay since we're only interested in the general indirect bounce. Our asset does not have mirror-like surfaces, so we won't see any lineup mismatches in the reflections. Now we want to set up our character path to have the set be part of the render, but not visible to a camera. So I'll create a DL Object Settings node and in the node switch off the camera visibility. I could just drag and drop the set into the cell statement, but I want to be flexible and be able to drive what exactly I want visible or invisible in the path through the shot work area. So I will create a collection in a sequence work and add the set to it. And call the collection set. And then create a second one and drag the samurai into the cell statement and call it samurai. To clean this up, create a group stack and add the collection into it. Now we have collections created and we can add them to the cell statement of the DL Object Settings node. Add a custom cell statement, drag in root, world, geo, and add a $char. Okay, so now if you click on the little arrow and select Find and Display the results, it'll show you what the expression applies to. And see, we get set HDB and ref. So these settings get applied to these two locations. The ref sphere's visibility is set to 0, so it won't render in the brute path anyway, so that's okay. Hit escape and render again. We should get exactly the same image, just without the set. Now if you compare this, it looks exactly the same. For a first pass lighting, this looks actually pretty good. I don't want to change anything at this point with the lighting. Now let's move on to setting up AOVs. When we pass our renders to downstream departments, we will always want to give them anything which can help them integrate our renders into the plate. Most of the times, the AOVs I pass to comp are per light outputs, so multi-light AOVs. If you will look at the DL settings node in here, this is kind of the master node for setting up our image layers and camera and quality settings. In this node, you can also set up AOVs. By default, only the primary is switched on. And if you look at the bottom bar of your monitor, under default, that's where you can see the AOV list. First, let's take a look at the multi-light output. This is where you can select the lights you want to output as AOVs. By default, it just shows the rigs, not the actual lights. Switch on display all lights, and now you can select the individual lights. To switch on the multi-light AOVs, just select them and that's it. You won't see them immediately. You need to restart the preview render to get the new AOVs. By the way, if you start a new preview render within Katana 4, you can now run more than one interactive render, which can be really useful. Make sure though to stop any render you don't need anymore. just hit escape on the renders, otherwise it might be too taxing on your computer. Select the drop-down menu. Now we can see all the different lights as extra AOVs. We want to switch on a few other AOVs. In the main window, select Add. A new window will open up where you can see all AOVs which are currently available. You can define your own AOVs, but 3D Light comes with predefined AOVs, and these are the most commonly used ones. As you can see, the window is split into three shading components, auxiliary variables, and user variables. Like I said, user variables will list any AOVs we defined ourselves. A typical auxiliary variable you want to switch on is Z-depth. Z-depth gives comp the ability to defocus renders and deep merge passes. Camera and world space normals are AOVs. If comp asks for them, we will usually output them as well. I want to show you how to use cryptomat in Nuke, so let's switch on the cryptomat AOVs. They can be very useful to isolate areas in comp. In shading components, we can basically switch on the components of the shader: diffuse, scatter, reflection, refraction, and so on. If you switch these on, you will get the shading component output per light, since otherwise you could only use the light AOVs or the shading AOVs in Nuke, not both together, as that would break physicality. Per light shading component AOVs allow you to do correct manipulation in comp. The problem is if you switch these on, I'm just going to show you quickly. So if you switch these on and if you render now again, you'll see we suddenly have a lot more AOVs. So if you switch on 3 shading AOVs and have 3 lights, you will get 9 additional AOVs. So using shading component outputs together with lights means you multiply your channels very, very quickly. This can be detrimental, confuse the comp artists, and make your renders heavier. Nuke also has a limit of 1024 channels, and one AOV would have 3 channels, R, G, and B. So with complex shots and with all these shading AOVs switched on, you will very quickly hit the limits of Nuke. So generally, I prefer to opt either the shading components or just light AOVs. So I'm going to remove all the shading AOVs because I don't really need them. I just want Z-depth and the cryptomat switched on, and the lights. The way our render output nodes are set up, if we take a look at our char_beauty render node, you can see the individual AOVs. The path for each AOV is exactly the same. I am setting the same path in the op script above and overwriting the individual AOV's path. 3D Light automatically writes the AOVs as a multi-channel AOV if the path is the same. Loading just one multi-channel AOV is much more convenient in Nuke than having separate files per AOV. I want to change a setting on Char Beauty. Click on the little wrench icon and switch off display output ports. So it will just display the numbers of the AOVs without the arrows. Do the same for Set Beauty. Switch off display output ports. Okay, before we render, let's load in the plate to double check the resolution and that everything looks correct. Load in the undistorted plate, since our CG renders are all undistorted by default. So it looks like we have a resolution mismatch. Okay, let's quickly double check what the resolution of the plate is. Go into Nuke and load in the undistorted source. And if you look there, the resolution of the undistorted plate is 2102 by 1109. So let's set those values in our Katana scene file. And go to Render Settings and set the resolution to 2102 by 1109. Now the render lines up correctly. Okay, hit escape and let's save this as a new file. I show you another new feature Katana has in version 4. There is Katana queue. So Katana queue lets you do more than one local render at the same time. And by default, you can run 2 renders. And since we now have everything set up, let's send a render to the local queue. Do a right click, go to Katana queue and select disk render. And this will send a job to the queue. Do the same for gray and the chrome sphere as well as the Macbeth chart. Okay, and once these renders are done, we will jump into Nuke.